All right, and just put in the, okay, so let's get started. The recording has started. All right, so good morning, good afternoon, and good evening, everyone. As always, from all the parts of the world, we have students and participants joining from everywhere, actually, so that's really great. And Happy New Year to everyone. And I hope it's going to be safe and a successful new year for everyone, and we will have a great and good time. And welcome to our second training program series being organized by Women in Astronomy Working Group of the IAU. And I would just quickly share my slide and then hand over to today's coordinator. So let's just get started. So share, yeah, so there we are. Right. So I'm Mamta Pomye, the chair of IAU Women in Astronomy Working Group, and together with Priya Hassan, who is co-chair, and Santiago Vargas Dominguez, who is from Colombia, who is an organizing committee member of our working group. We are very happy to welcome you all for the second training program of Essential Skills for Astronomy Research being organized by Women in Astronomy Working Group of the IAU. So to give you a quick information, IAU Women in Astronomy Working Group is a part of International Astronomical Union Executive Committee. And we are thankful to all the organizations in the world who are helping and participating in our activities, supporting our work. And we are equally thankful to the IAU offices who are supporting our work. So the aim of this Women in Astronomy Working Group, if you would have noticed during your registration, it is about providing training programs and skill building mostly to women and girls, because this is our working group aim to train young women and girls in astronomy. And there are many men and boys who have registered for our training program at different career stage, starting from masters actually up to even junior professor level. And they're equally welcome to get benefited from this work. It helps their career. We are very happy. So do not hesitate to register if you're interested. And we are doing this mainly, why we are announcing it mostly for women in astronomy. It's because the women are underrepresented in astronomy and in STEM fields. There are only 20% women, 21% women in astronomy worldwide. And there are very few women who are having permanent positions or senior researcher positions. So we want to help in skill building and in the career of women in research. So you will come to know more about all this if you visit our website, where you have all the information and research and documents which are existing. And now let's come to our second training program. And this training program, we have almost 90 participants from all over the world who have registered. And there were many registrations even this morning, so it's ongoing. So people are going to join as and when whatever topic that interests them the most or which is most closest to their research. It is based upon that. We will have different participants on different days. And so, of course, because we have so many participants from all over the world, it also shows that people are really interested in such kind of training programs. There is a need and one should be doing that. And we are very happy to do that with our organizing committee members. So once you have this training program, remember it's going to be 2 hours per day, starting from today onwards until 14th of January. And we are going to cover different topics. Today's topic is Sun Available for Everyone, Exploring Solar Images with a Visualization Software from Santiago Vargas Dominguez from Colombia. And he is the coordinator for today's program. We are going to register this program. And then we are going to put it up on our YouTube link. So you can always refer to the content of today's program on our YouTube page. And in the end, on the last day of the training program, which is on 14th of January, we are going to have, we would like you people to provide your feedback. So there is this feedback form. I have put the link of this feedback form on our training program webpage. So please go there and fill the feedback, because your feedbacks are important. It helps us to improve our training programs and helps us also to provide you the specific training programs that you need for your research. So with this, I would like to just add the final word, and that's this participation certificate. So if you're interested in having this participation certificate from the IAU, then do let us know. We will be sending you the participation certificates. And please join on our Slack channel and interact with our coordinators on the Slack channel, because that's where we communicate with all the students. We are not really communicating via email, mostly by the Slack channel. So with this, I would like to welcome you all and hand over to Santiago, who is going to coordinate with you today's training program. So please, Santiago, take over.
Okay, thank you very much, Mamta. Very happy to be here sharing this training program, the second version of this training program. So good morning, good evening, good afternoon, depending on when you are, where you are. And let me just share my screen. Okay, so for today, well, I'm actually going to share the whole screen, the whole desktop, because my idea is to interact with the presentation that I have, but also to be exploring in real time the tool that we are going to present today for exploring solar observations. But also I'm going to search for some information over the internet. So the idea is that if you can follow me on doing all these things, that will be probably the best for getting into the topic. So one moment, please. Okay, so basically the idea for today's training session is to explore solar images, because there are plenty of new telescopes, a lot of information, as the one you can find, for example, for night astronomy. But for solar observations, we can say that we are living a golden age for getting information from the sun, from different sources, different telescopes, instruments, and so on. So the idea is to have a look at some of these images, some of these data that we can acquire from different telescopes, and how we can use a software interface which is being developed in the last 10 years. Actually, the last update of this software tool was like a couple of weeks ago. So it's hard to follow all different updates, but the idea is that we can together explore this interface. So exploring solar images obviously is something that we are using or doing because we are very much interested in the solar dynamics at different scales. We have small scales, we have large scales in the sun, and we have also different temporal scales. And if we want to follow the evolution of the sun, we want to go for different instruments because every instrument is more or less specialized in one activity or region or information from the sun. So basically, the essential skills that I want you to know today can give you a rough idea of how you can explore data in, for example, the case that you want to prepare some analysis, research, or study. So the first thing you have to do is to concentrate or focus on a real example, a real data from the sun, because obviously we have a plethora of solar activity that we want to follow. So let me first show you these movies. Probably you have seen some of them because they are very famous over the internet and in YouTube. But the idea behind this is that you have a lot of structuring in the solar atmosphere, which is mainly composed by different layers. So we have the surface of the sun, which is what we call the photosphere. We have the chromosphere and the corona. And obviously, in the last 10 years, because of the evolution or because of the advantages that we have from different space telescopes, solar space telescopes, we are able to follow the evolution of the sun almost the whole day. I mean, it's 24/7. And that's obviously what gives you a lot of information, a lot of data. Probably you have also explored some tools or web pages where you can actually see what's going on outside in the space in between the sun and our planet. For example, this one is very famous, space weather. I don't know if you are aware of this one, but this is one page where you can actually see a lot of information what it's going on in the space. So basically you have the current conditions of the space, you have the information about the solar wind, density of protons, you have information about flaring activity from the sun. So for example, this one is from actually today, and you have X-ray solar flares going on here on January the 10th and January the 9th. And this gives you the information that basically you are interested if you want to check for a specific data. Obviously, this is only a thumbnail or rough information of what's going on. But the idea is that with this software, what we are going to explore today, we will have the possibility to explore, to deeper explore into this data. So for example, have a look at this one. This is from this morning. And this is getting ejected from the sun and going into the space. By the way, if you have any question, you can just interact with me. You can open your mic, or you can actually write in the chat. I will be checking the chat also from time to time. And also I have to say that if I have weak internet connection from time to time, probably I will switch off my camera, but I hopefully won't have to. Okay, so this is one of the websites I will recommend for the ones interested in being updated of what's going on with the space weather. Also, because I know there are many people that register to these training sessions, almost 100 people from different backgrounds. So we actually have like students, undergrads, and PhD students, and also postdocs and professors. So let me go from the beginning, explaining all different layers in the solar structure. As I mentioned, we have the core, the inner part of the sun, which is basically composed by two zones, the radiative and the convection zone. What we can imagine is that the sun is producing energy, and that energy needs to travel to the external part of the sun. So basically, once the energy reaches the surface of the sun, we have the possibility for the photons to freely move outwards and to permeate all the space, the external space. But the tricky point is that the atmosphere of the sun is very complex in terms of having different temperatures and different scales of activity. We also have another ingredient, which is the magnetic field. And I'm telling all this because this is what activates the sun, the interplay between the plasma and the magnetic field. In particular, if we go to the solar atmosphere, we have, as I mentioned before, different layers, but please have a look here at the temperature. So it's a large variation of temperature from 6,000 Celsius up to 1,000,000 in a very short distance in the solar atmosphere. So different from the Earth, where we have obviously also different densities and temperatures. In the sun, the variations are much stronger and more difficult to understand, because we still have a lot of questions, for example, on how the sun has this increment in temperature of 1,000,000 degrees in the solar atmosphere. What we basically do with the current telescopes is trying to do what I call a tomography of the solar atmosphere. So we're interested in tracking all the evolution of the solar activity from the surface of the sun to the upper atmospheric layers. And this is basically the tomography we are interested when we explore solar images, because we want to combine information from different layers of the sun. This is like we call multi-wavelength and multi-object solar research. And we can get data from different sources. Miss an S here. Oh, no, sorry, it's okay. So we have different sources for acquiring data. We can use ground-based telescopes, which is, well, the probably most common way of observing the sun since Galileo and so on. We also have the possibility to send telescopes on balloons or even in rockets. So there are plenty of science that we can do by observing the sun from balloons or from rockets. And also from satellites, obviously. We have spacecrafts which are designed to have solar telescopes on board, and those telescopes are specialized in different solar observations. So as you can imagine, we have a plethora of data, and one of the ideas nowadays is to be able to explore that data in detail, because at the moment there are many data that we are still lacking to proper analyze. But let me also mention one or two more details on how the sun works. One of them has to be with the way the sun rotates. So obviously, many years ago, we know that the sun rotates, but what we didn't know 100 years ago is that the sun rotates differentially. That means that the sun is not rotating as a whole, as for example, our own planet, but the sun rotates differentially if you go from the equator of the sun towards the north or the southern part of the sun. So this is a sketch where you can actually see some numbers here. 25 days is the rotation period of the sun if you are in the mid latitudes, well, close to zero latitudes basically. And then if you go upwards to the north or southwards to the south, we have a reduction. Well, reduction in the rotation, so the number of days increases, the period increases up to 35 days. So you see a difference of up to 10 days from the rotational period if you go from latitude 0 to latitude 90 degrees, which is the north part of the sun, or minus 90 degrees, the southern part. But this is something that you can actually detect by observing the solar surface. So actually one of the first things that we can do in our workshop is to follow the evolution of the sun and try to confirm, for example, if the sun effectively has this differential rotation. So I will comment on that in a few minutes, but let me explain this sketch here, this plot, because this is telling that this differential rotation behaves differently also if you go deeper to the inner part of the sun. That means that if you are on the solar surface, then you will have different velocities, different rotational velocities, depending on the latitude. So you have, for example, 0 latitude, 15 degrees, 30, 45, 80, and you see different values for the rotational period. So in the vertical axis, you have a way to measure the rotational period. In the x-axis, you have the distance from, well, actually, it's like a ratio between the distance and the radius of the sun. So meaning that if you are in number 1, you are on the surface of the sun, and you are 0.9, you are 90% from the sun center, 80% from the sun center, etc. So what you notice here is that if you are, for example, at 0.65 of the solar radius, you don't notice this differential rotation. But this is not something that we can measure by observing images, because one of the things is that for observing the sun, the energy or the photons that actually escape from the sun, you only have the possibility to do so if you are on the surface of the sun outwards. that means that if you try to observe the inner part of the sun, you can't, because the whole radiation is immersed, is how to say, is trapped in the inner part of the sun. So basically, the only chance to follow the evolution of the sun for inner regions in the sun is by other techniques. For example, helioseismology, which is applying the same techniques that we use on Earth to understand and to figure out the composition of the inner part of the Earth by analyzing waves, for example, on the surface. So in the sun, we basically do the same. We analyze the surface of the sun, looking for waves traveling all the way around the surface of the sun. And by analyzing those waves, you can infer the properties of the inner part of the sun. And this is what we call, once again, helioseismology. That's not important for today's session, but basically it's good to know, it's worth to know that we only are able to look at the sun to detect solar radiation from the surface of the sun outwards. And the last ingredient, which I'm going to comment here, is the interaction, as I mentioned, of the plasma and the magnetic field. So I'm explaining all this just because for understanding what's going on in the solar atmosphere, we have to know how the sun behaves in the inner part, because all the activity of the sun, which is revealed in the surface, in the atmosphere of the sun, is actually happening deeper in the interior of the sun. So here you see an animation, obviously, of the magnetic field, which is organized from north to south. And then because of the differential rotation, because of all these movements in the inner part of the sun, this magnetic field moves and it starts to create some tension, magnetic tension, and eventually it rises up and goes to the surface of the sun. Obviously, this is something that we are still trying to figure out in detail, because there are some models and we are trying to combine information from real data and simulations and modeling. And this is the way we currently believe that the sun is behaving in terms of the magnetic field being disturbed and going outwards. And finally, let me show you this sketch from 2008. This is a researcher, Sven Wedemeyer, and this is actually showing the very complex structuring of the solar atmosphere. So you have a lot of magnetic fields, different spatial scales, different also temporal scales, which are not shown here, but you can see the spatial scales. This is megameters, million meters. And this is just to point out that it's not an easy task to follow all what is going on in the solar atmosphere. And this is why we need more data, more telescopes to specifically point into one of these regions and try to see the evolution of this region and try to match the information from different layers and different regions in the sun. Probably you have already some information about the activity of the sun in terms of flares. The flaring activity of the sun, which is of very much interest because actually these events are the most energetic events in our solar system. And they are basically produced by the interaction of the magnetic field. Once the magnetic field is actually out from the sun, I mean, once the magnetic field emerges from the solar interior, crosses the solar surface, and then you have a lot of interaction, what we call magnetic reconnection, and this is releasing energy, a lot of energy, radiation, that you can actually also track in different solar layers. So in these images below, you have number 1, 2, 3, 4, 5, 6, 7, and this is showing nothing but the different layers and how the how these layers respond to the solar flare. Basically, you have brightenings, and those brightenings are revealing a lot of energy being released at this layer. For example, number 2 and number 7, you see more intense activity. And here is the classification of these flares from A, which are mild and soft solar flares. That means that the release of energy is less than 10 to the minus 7 watts per square meter. And you can have up to Z, which are more than 10 to the minus 3. And obviously, this also depends on how the sun behaves respect to the solar cycle that we are going to mention in a bit. Okay, so let me move to some of the information that we can start looking at. For example, if we want to look for information, update information on how the sun looks like right now, we can go to this website, which is called Sun Today. Sun Today, so you can actually go to Google and put Sun Today, and these letters LMSAL, that stands for Lockheed Martin Solar Astrophysical Laboratory, which is one of the institutions that has a solar group, very interested in the solar activity. And so they have a very large group interested in solar activity. Well, not only from the observational point, but also from the simulations and so on. So basically, in the Sun Today application that probably most of you know, if you are interested in the sun, you can have a look at different data from one of the telescopes, let's say recent telescope. Well, it was actually launched in 2010. It's already 10 years old, but it's probably one of the best telescopes that we have launched recently, because you have very detailed information of the whole disk, the whole sun. Because obviously, sometimes you focus in one specific region of the sun if you use, for example, high resolution telescopes. But if you want to have a look at the whole sun, this is probably the best tool you have. And this data is from yesterday. So actually, I don't know if they have already data for today's observations. Probably not. They have like a 1 day of delay. But this is from yesterday's solar observations, and you have different channels. Basically, every channel is telling you different information, but once you combine all the information from different channels, you have a feeling of how the sun is evolving in the solar atmosphere. So let me go through all these different channels. You have some numbers here, down here, for example, 304, 1600, 1700, and then a combination of different channels. So that means that this is the information from the channel 304, which means 304 angstroms. So this is the wavelength in which this image has been taken by this telescope. I don't remember if I mentioned the telescope, but it's the telescope called Solar Dynamics Observatory. Actually, I don't see the name anywhere here, but I will mention it a little bit afterwards. Yeah, I'm just checking if the name of the telescope was here, but it's not. But this is called the Atmospheric Imaging Assembly, which is one of the instruments on board this telescope. So once again, the telescope is called Solar Dynamics Observatory, and you have this instrument, which is basically a battery, group of small solar telescopes, and every telescope is observing different channels. So this is the 304 channel, and you have the possibility to get the whole image in full resolution, which is 4K. So if you press 304 and then go to 4K, you will have uploaded the whole image, which is actually much larger than this. Yeah, so this is the whole image. That's almost 4K times 4K pixels. And obviously you see a lot of detailed information from this layer of the sun, which I'm going to tell you a little bit later, which is this one. Okay, so if you are interested in exploring the data in detail, well, the idea is that you can use this tool and you can explore all different channels. But obviously I'm telling this first because it's the way, well, it's not the easiest way, it's one of the ways, but with the software we are going to mention today, this work can be done much easier. So once again, let me go back to this one. Well, you also have the possibility to only upload the small version, the 1K resolution version of this image. And what you can notice here, if you go from one to another one, is that obviously the information looks completely different, even though these observations are simultaneously done. And well, basically you have the same timestamps. Here you have the information from the time, which is maybe too tiny here. But if you go to from one to another, you see a big change in the information that the image is displaying. And this is because obviously the information is indeed different because you are tracking different layers of the sun. Also, you have the possibility to combine channels. So in this one, for example, you have the combination of 304, 211, and 171 channels. So let me go to the large version of this one in 4K. And down here, you see which channels are being combined. So you have SDO, Solar Dynamics Observatory, Atmospheric Imaging Assembly, which is the name of the instrument. This is the channel 211, which once again means 211 angstroms. And you have the timestamp. So this is from yesterday's 9th of January, 2022. And this is the time in UT time, 23:48:09. And the other channel is 304. And you see that the timestamp is a little bit different because obviously the images are taken by the same instrument in this case. So the instrument needs some time just to basically change the filter, but this is only like 4 seconds. So it's nothing that will put so much trouble because it's only 4 seconds and the sun at this scale changes in, well, minutes, not seconds. And the last one here, let me put this away, is channel 171, and then you have 23:48:09, so it's the same as the one up here. So basically the combination of the 3 channels is giving you, well, combined information, obviously, from different layers and different explosive events. But what you can recognize here is that there are some regions where you have a lot of activity, meaning a lot of intensification in the brightness. And these ones are what we call the solar active regions, but they are somehow related with what's going on the surface of the sun. Because remember that this is happening in the solar atmosphere. So this is a few hundred kilometers above the solar surface. Well, actually, the solar surface is not something comparable to the surface of the Earth, because obviously we have a solid surface in our planet. We have a very defined surface. In the sun is not the case. So we define the solar surface as the moment when the radiation can escape from the sun. Okay, so if you go further to the right, you have more channels. So you have, for example, here 094, 335, 131, and other channels with different wavelengths. This is again a combination of the 3. And here you have 211, 193, 171. This is a very common channel, 171, because this channel is tracing the magnetic field very good, I will say. So if you go to that image and you have the high resolution image, you will see all these coronal loops, basically. So this is magnetic field, but the magnetic field is revealed through the plasma, which is confined in the magnetic field. So it's not that you are actually looking at the magnetic field directly, but this is an indirect observation of the magnetic field through the plasma, which is confined and heated in the interior of the loops. Okay, as you notice, well, these are obviously individual frames, so you cannot analyze evolution of the sun unless you have more than one image, because obviously you need a movie, a time series of images for being able to track the evolution. So that's why we need more of these frames to be able to track the evolution of the solar activity. And this is what we are going to do just in a few moments. So lastly here, you have information from the instrument, which is called HMI. HMI is another instrument different from the atmospheric imaging assembly. So basically on board this spacecraft, you have two large instruments, atmospheric imaging assembly for doing all these different imaging, and the HMI, which is for doing basically my detection of magnetic field. So if you, well, obviously not only that, so I'm telling you the short story, but obviously you can go deeper into all the details of these instruments, but basically HMI is an instrument which allows to generate magnetograms, and that means magnetic information of the solar surface. So this, which is called HMI-B loss, that means B is a magnetic field, loss is a line of sight, so that means that this is telling you how the magnetic field on the surface of the sun looks in the line of sight direction. And let me open this one. And you have black and white information. So black means magnetic field entering the plane of the screen. White means magnetic field going out from the screen. And gray means no magnetic field. So basically you have a lot of black and white configurations. Some of them are obviously more intense than others. For example, here you see a lot of magnetic field, and this is white and black, so that means that there's some connection between the black and the white, but also you have a lot of tiny features going everywhere on the surface of the sun. Okay, so the magnetic information, what we call the magnetogram, is something that obviously you need to combine with the information from the other instrument to be able to see the interaction and interplay between the plasma and the magnetic field. Okay, so now that I have shown you this website, let me go to the first tool that I'm going to show, which is an online tool for exploring this, but much more easier than we are doing now. Just let me close down all these windows. If you have any questions, please feel free to comment on this. Probably this is something that you already knew. Okay, also let me mention that if you want to go to the original data in solar physics, there is a very common repository that is called Joint Science Operations Center. the Joint Science Operations Center. I forgot to say that the HMI stands for Helioseismic and Magnetic Imager. Remember that this is one of the instruments, and the other one is the AIA, Atmospheric Imaging Assembly. So the combination of the two is basically the main capability of this telescope, the Solar Dynamics Observatory. So if you go to the Joint Science Operations Center, which is jsoc.stanford.edu, you get the latest HMI images, also latest HMI movies, and actually they give you more information because now you have the possibility to see what's going on the sun by exploring these sort of images where you have information of the active regions which are appearing on the sun, and this is almost real-time data. I'm not going to go deeper into this one because we will see the other user interface, which is more comfortable, more user-friendly. Let me close down this. Okay. So we are going to Google, and we are going to put in Google HelioViewer, as you see here, HelioViewer dot. Well, obviously I have the whole link already in my cache memory, but if you Google HelioViewer, you will get to this website, which is basically a graphical user interface where you can get information from different instruments and different telescopes. As I mentioned, this is one, and the other one is a better version of this one. But let me first start with this one, HelioViewer. So I just need the confirmation that all of you are inside this website. If you have any troubles accessing the website, sometimes I've had troubles because in some cases there are many people connected at the same time, and obviously servers collapse, but I don't think today we will have that problem. Okay, so I put this one here. Okay, so what we have here is an interface where you can actually explore any data from different time ranges. So you have the possibility to go to any date. For example, if we go back to August the 10th, 2021, and then you have the possibility to update different layers here. Not different layers of the sun. Well, eventually, yes, eventually you are uploading different layers of the sun, but you can upload different layers, meaning that every layer means information from a different instrument. So let me just reduce the size of these windows here. Sorry, yeah. So we will start, for example, with this information here. You have the possibility to change opacity. That means that, okay. Yeah, but first of all, we need to upload an image of the sun. So if you go here to, once again, August 2021, 10th of August, and then you have the possibility to have information from different solar telescopes. I don't know how aware you are of different solar telescopes, but for example, you have the SDO, which is the one I'm commenting more in this presentation, but also you have SOHO, which is a very famous solar telescope launched in 1996. You have also the possibility to explore SOHO data. Stereo A and B, this is a couple twin satellites, twin spacecrafts that were launched in 2006, and they have information from a different point of view than the one we have from Earth. So stereo A and B. JOCO is another Japanese mission, Proba 2. So you have, well, quite a few possibilities. But let me go to SDO because it's the one that I showed before from the website. And here you have to activate this, which is how you activate the image. You can use your trackpad if you want to zoom in or out. And this is the image from the 10th of August. Actually, if we go to the current date, the home, January the 10th, we can see if we have the updated image. And yes, this is the image for today's solar observation. And also not only the telescope, but the instrument. So as I mentioned before, you have two instruments in SDO, AIA, HMI. And for AIA, you have all different channels. So remember the ones we were looking at before at the beginning. We can select the wavelength and we can actually upload all different channels here. Well, as you see, there is also a change in the color of the image. But basically, this is something which is not related to the wavelength. That means that obviously these wavelengths, most of them are not visible, are not part of the visible range of the solar spectrum. So basically, we use the color as a tool, and we can use different colors, obviously. But SDO has a color palette, and for example, for a 211, they use this color, which is like purple. But if you go to 171, they use the yellow, and if you go to 94, it's more green. So basically, don't get confused because these colors are not telling you that you are in the visible range, which is obviously the one for the colors we can actually look by eye. It's only a tool. You can select a different color, but what you have to take care about is the information which is telling you this wavelength. You have the Earth scale here to compare the size, obviously, of the structures that you are looking at. For example, this active region compared to the size of our planet. Okay, once again, let me repeat very briefly what we have done here. So we can select the date up here. We have the possibility also to explore images before and after. So you can select here the jump that you are going to do, for example, 1 hour. And if you use these arrows here, you can go, well, obviously you cannot go 1 hour after because this is the last image. So you have to go backwards in this case, because we are in the very last images observed by this telescope. But you can jump 1 hour before and so on. So as you can notice, every time you change or you click this arrow, the image is changing a little bit because the sun is rotating. So you will experience a very tiny shift in what you are looking at. Obviously, if you want to see larger jumps on how they look, you can go 1 day prior to this observation, and then you will see a big change. Well, not that big, but so we are almost manually rotating the sun, but just because we are looking at previous images. And this is something that is now giving you evolution. Obviously, this is a sequence of frames where you can see evolution of the sun. By that, I mean that, for example, you from time to time will see how these regions appear or disappear. Obviously, they can disappear because they go to the limb and they just go away. That means that they only disappear for you because of your position, but also sometimes you can see how they disappear in front of you, or at least increase or reduce in size. Okay, but now we can actually combine more information. For example, if we add more layers here, which I already have some, but let me click on add layer, and we add, yeah, this time we added this one here, LASCO C2. And LASCO is a coronagraph. It's an instrument which is on board this other telescope, SOHO. And LASCO is the name of the instrument. Sorry, there is also IAT and MDI, which are another instruments on board this SOHO mission. But for LASCO, you have also more possibilities, C2 and C3. That means Coronagraph 2 and Coronagraph 3. So at this moment, we have C2, which is this coronagraph, which is giving information of the outer part of the sun. So actually, you are now, well, this is the way you can change the opacity. If you want to mix information from one, obviously, in this case, you don't have mixed information because one is showing only the full disk and the other one is far away, it's showing external part. But just imagine that you have more information of the same region and you want to change opacity of one or another, you can do that. We will do that in a moment. So by now, this LASCO, as I mentioned, is showing the information of the material which is being ejected from the sun. So basically, you have these tools for exploring solar wind, if you want. And again, you can go one day farther behind or ahead. And in this case, both images are being changed. For example, here you see this information, you can zoom in. And we have this brightening here, which is somehow connected to this emission here. So if you want to go in more detail, probably you will have to reduce your jump time. And then you can see a little bit more in detail with better temporal resolution what's going on. Obviously, here you have misinformation, which is this black shadow here, because the coronagraph is blocking the information, well, blocking the light coming from the sun, but also blocking a bit more. So it's 1.7 solar radii, which what you don't see from this coronagraph information, up to 6 solar radii. And if you want to look at more information even farther away from the sun, then you have to upload the other coronagraph, which is called C3. So you go to add layer here. And basically, wait. Okay, we have a limited number of layers, but I can use one of the ones which is not in use now. For example, this one. So I can put SOHO mission, LASCO instrument, C3 detector, and I click on this eye just to activate this layer. So this is LASCO C3. And LASCO C3 is covering up to 30 solar radii. So this is what I was telling before, that, for example, here you have a combination of information from the LASCO C2 and LASCO C3. That means the orange and the blue. So if I change the opacity, I can see how they are overlap. Once again, the color here is only a tool for painting the information. So you can actually change the colors here. If you go to, let's see, no, well, C3, this is the default color that is being used, but you are able to change the color if you want. I don't recommend that because obviously there are some standard colors, and if you change the color, probably, well, the information can be misunderstood by others, basically. Okay, what else you can do from this one? Last thing you can do here is you can activate the options to explore different features. What does it mean? That means that this heck can give you the option to activate different regions so that the software can automatically detect some figures, for example, active regions, coronal cavities, coronal dimmings, coronal holes, etc., etc. I'm just checking that this is working or not. Well, actually, prior to doing that, let me put the image of the solar surface, the photosphere, here instead of this one, which is channel 9.4 at the moment. Let me put HMI, but HMI, I mentioned that it's basically for magnetograms, but also it has a possibility to get a continuum image. That means an image of the sun in white light, in the visible light. So this is the image. And sometimes because of the size of the images and because you are uploading a lot of information, you will have some problems with the memory of your computer or laptop. Okay, but basically the sun looks quite blank today. Well, a few dark regions here that are mainly small pores, what we call solar pores. They can evolve and they can increase their size up to, for example, turning into sunspots, which are larger. But at the moment, it doesn't seem to be very active. Oh, sorry, there is some, yeah, I'm doing something wrong. Well, not wrong. I was a little bit confused because the date here is December 2021. So I thought we were already in 2022, which if we go to January, then we will have, okay, now it's working because yes. So this is already the updated image of the sun from 24. Let me see if we have on the 9th. Yes, okay, yeah, now I'm not confused anymore because I knew that the sun today is displaying some sunspots. So I was a bit lost because of the dates, but now this is an image from yesterday. It's the last image that you can upload in this interface, and you have sunspots. Okay, so now we are happy with the sunspots, and they are revealing a lot of information because you have a very dark part in the inner part of the sunspot. You have a penumbra here, and if you want to combine this information with another one, you can, for example, upload another layer. Let me use this one here. So I'm going to put SDO. I'm going to put the AIA instrument and the channel number 171. 171. Obviously, you have to activate the eye here, but because this layer is behind, you cannot see this layer unless you unclick this one. So if you activate or deactivate the HMI one, you can have both. But as I mentioned before, you can also change opacity, and then you will see how both images are connected somehow. So you can identify, for example, how the connectivity of the magnetic field between the two sunspots is organized. So this is something that we basically do a lot of time because we are very much interested in the connections of the magnetic field. But obviously this is not magnetic field. This image is in white light. So it will be better if you have the information from the magnetic field just to test the connectivities with the magnetic field. So in that case, you will change this white light image here for another image, which is actually a magnetogram. So you can, again, use SDO, HMI instrument, the magnetogram here, and this is already magnetic information. So in that case, you have, again, black for negative polarities, white for positive magnetic polarity. And here you can see the connectivities. So for example, you can identify how this large patch in white is connected to, for example, these tiny ones in black. Let me zoom a little bit in here, if I can. Okay, probably, okay. Okay, I guess that's the maximum, yeah. Okay, the maximum zooming I can achieve. So once again, have a look at the connectivities. Well, I'm wondering if you have any questions so far, if you are following me, because right now I'm going to move to the definite tool that I will show you and the one we are going to use from now onwards to actually the next session as well. But before that, I just want to make sure that you are following what I'm telling. Yes, someone is going to say something, please go ahead. I listen to someone with the mic open, but I don't know.
We are following.
Okay, okay, thank you very much. Thank you very much. Okay, what else we can do with this image? Because obviously there is a lot of information that we haven't actually explored. So let me, for example, obviously we have some limitations here with this interface because, for example, you cannot upload more than, I guess, is 5 layers. So we have one here, another one, which is LASCO C3, another LASCO. Well, actually, we can use this one, which is deactivating now. Let me go to this one here, and we can upload another data. For example, we can upload what we can put here, SDO, another channel, for example, AIA, and let's put here the channel, which one? 304. 304 is a very nice channel, you will see. So again, you have to activate here the eye, and the image is behind this one. So if you deactivate HMI, you will see the channel we have just uploaded, this one, 304. Okay, 304 channel in the orange. This is giving information from the chromosphere of the sun, from the chromosphere. So once again, you can change the opacity here and you will see what it's behind. And you can activate this one. And for example, you can have the 3 channels with half opacities and try to see how they mix. Obviously, you will have confusion information, but anyhow, you have the possibility to do so. Okay, let's have a look at the whole sun with all different channels here. Just to recap what we have done. So in the center, we have the full disk of the sun with different channels. One is HMI, magnetic information. If I deactivate that one, the one behind is the 304 SDO. And if I deactivate this one, also we have the information from behind, which in this case is AIA 171, the channel 171. That's the one in yellow. If I deactivate that one, I don't have anything behind, because what I have left is the information from the coronagraphs, LASCO C2 and LASCO C3 in blue. Let's check here. Obviously, I don't have the channels in order. That's my fault. But anyhow, LASCO C3 is the blue one here, and LASCO C2 is the orange one. Okay, this is planet Venus. And you also have some cosmic rays here, for example. This is basically a cosmic ray. And sometimes you can actually identify a comet here. Obviously, because of the field of view being a bit large, you can actually see a lot of things happening around the sun. Okay, what else? What else? Let me just see some options. Okay, you can also make a movie, because obviously if you are, well, the problem here is that if you want to do a movie, you have some restrictions. As I mentioned, you can actually move around in time. Well, I cannot go further in time because that's the last image, but if we go to previous images, I'm jumping here in 1 hour steps, and you see how things are changing there. Let's jump in 12 hours. Junks, okay. So obviously you will notice even the movement of the planet Venus. Okay, and this, what is, let me put it here, okay, here, because you have some information here. So let me explain what does it mean. Okay, so I have a question from Rogers. Thank you, Rogers, for your question. Yeah, he's asking if the temperature of the chromosphere and the photosphere is different, and not only that, but yeah, the chromosphere, he asked, is less than the photosphere. And no, the answer is, if we go to the slides again. This is the slide where you have the information on the temperature. So you have the photosphere, the surface of the sun, 6,000 degrees in Celsius. And if you go farther away from the surface, the temperature starts to increase. Oh, well, not increase in this case, you have 4,000. Well, yes, but the variation is not much. Actually, 6,000 degrees here is a rough temperature, it's a mean temperature, because obviously you can have sunspots, and the sunspots itself are even at lower temperature. So I will actually comment on that in a few minutes. But yeah, you have some changes here. It can reduce a little bit the temperature, but basically what you observe, what you measure in the solar atmosphere is that the temperature rises up quite a lot. But yeah, you can have some tiny, well, tiny means a few hundred degrees variation to lower temperatures, as from 6,000 to 4,000, but that's a tiny variation compared to the one you will experience if you go farther away from here. Okay, thanks for your question.
I also had a question.
Yes, please.
So we are studying the sun in different wavelengths. So according to what I understand is, the telescopes record the wavelength that falls on it, like because of the expanding universe or something like that. So I'm not understanding, like, how are they able to study the sun in different wavelengths? Because like we'll get one
Yes.
type of light. Uh,
Yes. Yes. So yeah, you're right. So we have different telescopes, different instruments, and every instrument, I will say, is specialized in a certain range of the solar spectrum, of the electromagnetic spectrum. So you have telescopes, for example, looking at the sun in visible light, some in the ultraviolet light. Actually, in the ultraviolet, you still have different ranges. You have the near ultraviolet and the more extreme ultraviolet and so on. And yes, by changing the wavelength, you will have information from a different layer of the sun at a different temperature. So your question is how we combine this information from different layers. And for example, here, because obviously the information is different. So if you go from the photosphere here, you will see, forget about the colors again, because I put green color for the photosphere and blue, yellow, orange, but again, the colors are only a tool for putting the images in a certain manner. But if you go not to the color, but to the information in the image, you can see sunspots here, for example. In the photosphere, you see sunspots. In the chromosphere, you see again the sunspot, but you see some changes around the sunspots. So you see more brightenings around. And if you go farther up in the chromosphere, this is the chromosphere. I have to reduce let me just reduce here. Okay, so the chromosphere, you see still the sunspots, but then you see a lot of filamentary structuring around, different from what you have in the photosphere. So yes, the information is different. And the tricky point is how to connect all this information up to the corona. In the corona, you don't see sunspots anymore. Instead, you see brightenings. So actually, when you see a sunspot on the photosphere, that is telling you that up in the corona, basically, or most of the time, you will see brightenings, explosive events. So how the sunspot, a direct structure on the surface of the sun, is connected to a bright structure upwards, that's the tricky point. That's what we have been doing in the last decades, trying to connect all this. Imagine this is basically the same when you have a tomography of your brain, for example, or your lungs, whatever. And you have different information from different layers. You have slices of your brain, for example, and you want to connect the information and try to do the puzzle. So it's try to complete a puzzle with different pieces, and every piece is slide with information from one surface of the sun, from one layer of the sun. Okay.
yeah, thank you. Understood.
Oh, thank you very much. Okay, anything else? Any other question? Okay, because now I want you to, well, probably we won't use this tool, but this is an excellent tool, obviously, but it has some limitations, as I mentioned before. So to finalize with this tool, just let me show you what these bullets here mean. So if you go down here, you have this heck. What does it mean? This means that you have the possibility to activate or deactivate different features that can be identified or recognized in the sun. At the moment, for example, we have active regions here. I can activate or deactivate. And if you, let me go step by step. So I will deactivate all the others and only activate active regions. And look what is going on. So active regions mean these regions where you have intense magnetic activity. And this is a tool generated by artificial intelligence applied over the images in real time. So you have, well, the groups doing this have algorithms that can identify features, structures. So in this case, this is only telling you that this is identified as an active region. And this is a number in here. Obviously, you have to identify a region with different numbers. So this is why this is 26500 and this is 26511. And if you go to the information from the surface, let's go back to the surface of the sun. Oops. Okay, I'm deactivating everything. Okay, I missed the surface, which is, yeah, if we want to see the surface, we have to go from magnetogram here to continue. So all this is what we call an active region, As you notice, the active region can have more than one sunspot. So this is one sunspot, this is another group, this is another one. So in this case, you have multiple sunspots, but all of them conform this active region. Okay. Here on the left, you have, let me zoom in. Okay, this is the maximum zoom I can do, but all this region is also an active region. So the software, the algorithm identifies this automatically as an active region. And if you go up, there are a few more. So here you also have active region, even though we don't have sunspot. But you see that there is some brightening here. So apparently it's something happening here differently than the actions happening around. So I don't know if the resolution is good enough for identifying some brightenings here on the surface of the sun. So not in the corona, because that's normal or more normal. Let's go to the other one, which is somewhere here. Okay, another active region. But apparently there is nothing relevant here. Sometimes in white light, so in the continuum, in the visible light, you don't see anything. But if you go to the magnetogram, then you will see something. So in this case, something abnormal. By abnormal, I mean different from the average. So in both cases, you have some information. Obviously, for these two is more evident because you have a lot of black and white being concentrated. Okay, I have another question, Nimi. As solar system moves through the galaxy, do these images show the change in position of celestial sphere around sun after sun? Okay, so Nimi is asking about how the movement of the whole solar system is evidenced here, probably, or how it changes the situation here. And basically, in this case, it depends on where the satellite is located, because we have, as I mentioned at the beginning, we have ground-based telescopes. Well, obviously, in this case, they're not important because we don't have the possibility here to go to any ground-based telescope. So all of these are satellite telescopes. All of these are in space, but some of them are closer and some of them are farther away from the Earth. So for example, stereo A and B, these two satellites, they are like twin spacecrafts and they go farther away from Earth. They are actually orbiting the sun in the same orbit as the Earth, as the Earth's orbit, but they are farther away from the Earth. So basically, the way they both look at the sun is different from the one we look from Earth. But I will comment on that in the next user interface, which I'm going to show because it's easier to understand the situation. But yes, the way the images look very much depend on the way the telescope is located. So in this case, SDO is as if you were looking at the sun from Earth. So you see basically the same information, the same direction towards the sun, SDO, not the stereo A and B. Actually, we can change here from SDO to stereo, and you can notice the change. So if we go, let me change this blue image here, which is Soho Lascaux C3. Yeah, Soho Lascaux C3. So instead of that one, let's put a stereo A. The coronagraph for a stereo is not called Lascaux, but Secchi. This is honoring Angelo Secchi, which was a very famous astronomer, Italian astronomer from the 18th or 19th century. So we go Secchi, and we can use core 2 or 1. These are the coronagraphs. So let's go to core 1. Core 1, and let's see if we have some information, which probably we don't have because of the delay. So yeah, some of this information is not uploaded at the same time the image is acquired. That means that if the telescope acquires the image today, probably tomorrow or in 2 days' time, you will see the image in this platform, in this repository. So this is the case here. I don't see that we have images from a stereo A for today's observation. So we can go, for example, to the 1st of January. 1st of January. Oh, sorry, I also did something wrong. And is that obviously we have to activate it. Okay, look. Okay, look. So let me go back again to today's observation just to. This is. Oh, wow. Look what I did. I deleted the whole layer. So if you press this X, you remove the whole image layer here. And that's what I have just done. So let me add another layer here. And you can put a stereo A, instrument Secchi, detector core 2, activate the image, and this is core 2. If we put core 1, and this is the image. Okay, so let me activate core 2, sorry. And this is the image in orange from the spacecraft stereo A, instrument Secchi, and the detector Coronagraph 2. Okay, and the information looks, well, quite about the same, but is not the same, because actually this stereo A is looking at the sun from the side. Actually, the A stands from ahead, the stereo ahead. That means that this is looking at the sun from a position where you can actually see what's going on in the sun ahead. Okay, but by now, I won't get more into this just by now, because I don't want to mix some information and to get you confused. So at the moment, just work as if we were always looking at the sun from Earth. So from the point of view of Earth. What I want you to do now is to reproduce some observations. I don't know if going now to the next tool. Yeah, probably I won't go much more into this one, because this is not the one I want you to use. Obviously, you can use it. It's online. You don't have to download anything in your computer. As you notice, the only thing you need is a good internet connection if you want to upload data easily and rapidly, because obviously this is going into the repositories of all different telescopes, and this is bringing the data into your interface. But yeah, unless you have any other question at this moment related to what I have shown, we can move to the other tool, which is the one we're going to use from now on, which is more sophisticated. Obviously, you have much more options. You have the same options here, but much more, and is more reliable, I would say. Okay. Okay, so if you don't have any more questions, let me show you what's the name of the other one, and it's called J HelioViewer. So instead of HelioViewer, is J HelioViewer with a J ahead. So J HelioViewer, you can go to Google, you can Google it, and it's right here, J HelioViewer. So let me click there. Okay. So what you have here is a website where you have the information from this this tool, which is basically, well, it has the same possibilities as the other one, but this is more robust and more reliable, as I mentioned before. So you have a lot of information here if you want to deeper explore all different options, etc., etc. But what you probably want to do now is to download this, because this is an application that you actually download in your computer. You have the possibility to download it for any operating system. It doesn't matter you have Windows, Linux, or Mac. So please, if you haven't done so, please download the J HelioViewer in your laptop. I don't know how big it is, but it shouldn't be too heavy. It's like probably 100 megabytes or less than that. And I will wait just a few minutes for you to have time to download it. They have two versions here. This is the one which is more robust, and this is the beta version. As I mentioned also, this tool is being updated from time to time. So actually I downloaded yesterday the last version with the last updates, which are from December the 12th. So only a few weeks ago, they published the last version. So it's sometimes hard to follow all different updates that have been done on this software. Okay, from here also you have the possibility to explore the documentation. And actually we are going to pretty much we're going to go into the user manual. Actually, let me check it now, because in the user manual you have a long list of possibilities. So this is just for you to see how many possibilities you have with this software to do a lot of things to explore solar data. And as I mentioned also at the beginning, this is something that you have to do if you are interested in a specific event. Then you will first have to have a look at the situation, have a look at the images, probably to create a movie. And with a movie, you are more into what's going on in the region you are interested in. So this is just a very rapid view of all the possibilities that we are going to explore in this training session in the next minutes, but also basically that's the main core of Thursday training session. It looks a bit long, but it's not. I mean, it's quite easy. And yeah, as always, you have to do it by yourself. And you will see that it's easier than it looks. but at least this is giving you a sneak peek of all the possibilities you can explore with this J-Helio viewer. And actually, the software will have a lot of new possibilities in the upcoming months or years, because we have new solar missions. You might be aware of Solar Orbiter, which is a mission launched in February 2021 or 20, I forgot, 2021, no, 2020. And the Parker Solar Probe is another spacecraft launched in August 2018. And these two missions are obviously producing more data, and they want to integrate this data, this new data, with the data that we have already in the repositories. So basically, what we are doing is what is called multi-messenger solar physics. Multi-messenger, multi-instrument, multi-wavelength solar physics. Okay, so if you have already downloaded, I hope you don't have any problem downloading the software. So I can go to my own J-Helio viewer, which is down here. Mine is it's a Mac. Okay, so let's see what's going on here. Okay, so it's here opening. Okay, now, yeah, it takes a little bit. Okay, perfect. So this is the appearance of the interface. So basically, you have the screen where the images will be displayed. But also you have, well, as you notice, a lot of new tools. You have a menu here with many different options, and you have, again, the possibility to put some layers. So here you can create new layers. You have also the possibility to explore data from any date. But one of the new things here is that you have the possibility to play a movie. So if you put, for example, an initial time, an ending time, you can play a movie, and the movie is appearing here in real time. So let's do that. For doing that, so what if, for example, we look at the last week? What has happened in the sun in the last week? So that means that we go from January the 1st up here to January the 10th, today's observation. So now we have set initial and final times here. But now we have to select information. So we can create a new layer, and you have a lot of new possibilities here of instruments and so on. So let me show you. You have information from ROB, which means the Royal Observatory of Belgium. That's one of the places where you have a repository of data, and you have a lot of information, not only from satellite telescopes, not only from space, but here you have the possibility to get ground-based data as well. For example, you have this Kanzelhoe. This is an observatory in Austria. In some cases, you have redundant information. For example, you have SDO here from the Royal Observatory of Belgium, but you also have SDO from this one, which I don't remember now specifically, which is this repository, but you can choose which one you are going to use. So for example, if we want to do what we did before, then we use SDO data, and you have the possibility of AIA, HMI, etc. What I don't see here, for example, is the other channels. So if you select this one, we only have 171 and 304, but we don't have the other ones. You remember that 94, 1600, etc. So let's check the other one, which is IAS for SDO. Okay, so here you have all different channels. So this is obviously something that depends on what you are interested in. If you want to have all different channels, you better go to this one. So let's go to 171. 171. So this is already loading the information. It probably takes a while, but that means only a few seconds. And this is the information. Obviously, it's not only a single frame, but you are uploading a lot of frames. So it finishes uploading the frames. This bar is completed here. And then you can play and see what's going on. Okay, so let me just expand this window if I can. Okay, yes. Okay. So this is much more interesting because now you are evidencing the activity of the sun by looking at all different frames. And as you notice here, this is jumping from frame to frame. If you want to accelerate or deaccelerate this movie, you have the possibility to increase or decrease the number of frames per second. So if you go, for example, if you want to go faster, let's see if it works, because probably they have a limit. As you see here, there are 97 frames. Let's put a number like 10 frames per second. Then you press enter. Okay, yeah, I think this is because you have to synchronize. Yes, every time you change something up here, you have to synchronize so that the information goes to the actual data, which is down. So we can press synchronize. Let's see if this works. Well, in the meantime, you have the possibility to loop the sequence of images or swing or stop at the end. You have the possibility to change the size of your displaying window. And this is the possibility to change the time. Okay, if you have any questions, just let me know. Just to want to make sure that you are following or you won't have problems. But as I said, this is something that you can actually explore by yourself in more detail and see all different options, because they are very user-friendly, I will say. It's not hard to notice what the tools are for. For example, multi-view here, I'm going to explore some of the ones up here. Well, obviously zoom in, zoom out, zoom fit, which is a default dimension of the displaying image. If you want to move around, you can use this pan here. If you want to just click on your trackpad or mouse and move around with the whole sun. But you can also rotate the sun manually. So if you rotate it, obviously this is showing how the information is missed from behind the sun, because you are looking at the sun from the point of view of the spacecraft, of the telescope. And this is basically the same as we have in our local position on Earth. So all the information from behind is missed. So we don't know what's going on behind the sun. unless we look at the sun from behind. And also you can change your axis here. Okay, so this is to rotate and sorry, to change the azimuth, and this is to change in the other degrees of freedom. One of the things that you can notice here is that the information coming from the central meridian of the sun is unprojected. So that means if you go to the limb of the sun, because of the projection effect, you will see that the areas or the dimensions or the structures change. So what I mean is that if we move around here, you see how the images are stretched as you go to the limb of the sun. Well, it's not the limb here because I'm putting it in the central meridian, but what I call the limb is when you observe the sun from Earth, you have a disk, obviously, and you have the borders of this disk. That's what we call the solar limb. We want to look at this solar limb, and we want to put it in front of us. You will see the projection effects that are affecting this part of the image, but also if you go to the other limb, you will see the same effect. So this is information that is less trustable because it has been affected by projection effects. So that's why we need, if we want to observe exactly what's going on here, you need a telescope observing from the side, because the less you have these projection effects, the more reliable the information is in terms of area and geometry and so on. Well, okay, so let's stop here for a moment. We also have the possibility to upload more than one image as in the other tool, but we can also put it in the same frame or in a different frame. What I mean is that if you upload a different layer, for example, AIA, and let's go to 304. Okay, that's another layer which is outdated, and it says error getting the data, no data is available. So in this case, we have problems because as we are looking at the very latest data, in some cases the data is not available. As I mentioned before, sometimes you have to wait a few days for the whole data set to be available. So this is what's going on here, as far as I notice. So what if we go to the previous year, just to make sure that we have all the data? So if we go to the 1st of December 2021 up to the 8th, so we are covering the first week of December last year. I missed something. Yes. Once again. Okay, December the 8th. Okay, so now it's okay. 1st of December, 8th of December, and synchronize. So we are synchronizing the data, and this is taking a few seconds to upload the data. And this is already our data, which is, as you notice here in this bar, this is telling you that it's uploading the data. So once it finishes, you can play the whole movie. Okay, so this is what's going on in the sun the first week of December last year. A lot of activity going on. The sun is rotating, as you can see from these images, but what it's not it's not difficult, but you have to go deeper to prove the solar differential rotation, because then you have to focus in different latitudes And you have to follow, for example, one of these regions and try to measure how long does it take for this to go from the west to the east limb at different latitudes. And that's a way you can prove the differential rotation of the sun. That's something that you can do quite easily. Okay, but once again, don't lose focus here. I want to upload 3 or 4. I want to upload another set of images from the channel 3 or 4, observed with the Solar Dynamics Observatory. So this is loading information here. Loading. Okay, so here we go. We have the information. I can use my trackpad to zoom in or out, and somehow because of the 2 different fields of view, you see how the information is displayed. But obviously this is different from the one we were more used to. Any questions? Okay. Okay, so how do we put the information in the same display? Just by changing the view. So you have this multi-view option up here, or the normal option. In the normal option, you have combined information. Then if you want to see what's behind, you have to click here on the left. So we have no information, we have 3 or 4 information, and 171. But this is already combining the 2. So if you want to have a look at the 171, you have either to uncomment this one and click and tick the 3, or you have to, let's see, what's the other option? No, I guess that's the only possibility, unless, yes, if you change the opacity, well, you can change opacity here, but if you click on the other one, anyway, you will have combined information, unless, even if you change opacity at the 100% opacity, you will have mixed information. Okay, yes, I will finish very soon. Because now you have a lot of things you can explore. And basically what I will finally do is to give you a sort of homework or something that you can explore. So if you go, well, if you use Twitter, I will recommend you this Solar Ham, which is an account where you have a lot of information from the solar observations. Actually, remember that you will have also training session about Twitter and social networks. So this will be a good opportunity to follow the Solar Ham. And in the last publications from Solar Ham, you will see, for example, this from today's. You have the information from the SOHO, from the Coronagraph in SDO, the blue information. That's SOHO, yes, SOHO, I was wrong. SOHO LASCO C2. But the homework for you is this one. I want you to explore the information and to use the coronagraphs and try to follow these events here. On the left, you see something that we haven't explored, but let me tell you very rapidly because it's not difficult. If we upload LASCO, so let me go here to LASCO, that's in SOHO. Oh, sorry. SOHO LASCO C3. Okay. So this is uploading here the information from LASCO. Remember that this is a coronagraph where we can have information from what's around the sun. Okay, now we have LASCO. By the way, you have this very tiny information here that is the whole field of view. Okay, one moment. This is doing something strange just because the data hasn't been uploaded completely. Okay, this is Glasgow. You see a very nice event here, for example, and this is showing a coronal mass ejection. But if you change these possibilities down here, you see that you have known difference, running difference, base. If you click on running difference, this is showing the information a bit different. What does it mean? A running difference means that you are subtracting information. So you are using the second image and you subtract the first, and then the third to the second, and then the fourth to the third. So that means that you are actually looking at changes from one image to the next one. And in this way, you can highlight the changes. For example, here you can highlight all the changes due to the coronal mass ejection, and it's easier to identify what's going on here. So black and white means that if it is black, it's because the value reduces from one image to the next one. If it is white, it's because the pixel value increases from one image to the next one. So once again, if you go to known difference, is the normal images, one after another, a time series of images. If you go to running differences, that means that you are subtracting images. 2 minus 1, 3 minus 2, 4 minus 3. And this is a way we highlight information. I'm telling you this, obviously we're going to comment on this on Thursday, but just because if we go back to this one, this is the way they are presenting the information here. So they are doing running differences on December the 20th last year. And this is showing a coronal mass ejection. So what I want you to do is to reproduce with this software, with the JHelio viewer, these images. This one, which is for another date. And probably these ones, well, not this one, because this is changing the coordinates. I'm going to show you next Thursday how to do that. Or you can also explore all different options. Actually, I encourage you to explore by yourself some of the options and see if you have any troubles or any questions. And finally, this one. Because for next Thursday, we will follow the evolution of one of these coronal mass ejections. We are going to follow the evolution in a sequence of images, and we are going to infer the velocity expansion of the CME and a few more things. So I'm going to put these images in the Slack channel so that you can have the information. Basically, what I want you to do once again is to use the interface to reproduce what's going on here. I mean, to reproduce the same observations that are being displayed here. Also, if you want to explore more events, you can do so. And on Thursday, probably I can ask you if you found any interesting event to look at. Okay, so it's already 30:30, well, depending on where you are, but it's already time to say goodbye for today's training session. I don't know if any of you have any question, final question or comment, or anything you might want to share. I'm going to open my video again. Okay. I hope you have the interface running smoothly, because sometimes you have problems with the connection, and also because of these images being quite huge, you will have troubles. Actually, if you, for example, upload the whole year of solar observations, you will have a problem, obviously, because your computer will collapse in RAM memory. Okay, so that's all from my side for today's training session. Thank you very much, and I give the word to Mamta. Thank you.
Okay, thank you very much, Santiago. That was really great. And I think we want to explore more and try to understand more than how sun works, especially after this particular training session. It was really interesting, at least for me, and I'm sure for others as well. Do we have any question? Okay, we have a comment. Thank you very much. Very informative session and amazing session. I've learned a lot, so that's great. So I guess Santiago is going to share the tutorial or some exercise on the Slack channel. And I'm sure people are going to be tempted to try and produce images like you showed and do all those manipulations that you've shown with the images. And please remember, everybody, all these tutorials that you're getting, please try it out. It's always interesting. You get to learn new things. And if you submit your tutorials to us, and if you wish to have the participation certificate, then do please submit your tutorials. And we will be, of course, choosing one best participant during this week. And he or she is the one, especially it will be she, is the one who is going to submit all the tutorials. Any questions?
Yeah, just to remind you that I will share the information in our Slack channel. I will put all the links that I have shown today and also the images for you to explore and to reproduce the observations. And well, I hope you are all with me next Thursday, and we will see a lot of details of this interface. Once again, from the beginning, I show other possibilities, but this one is the definite one because it's the one with more information, more possibilities, and the one which is being updated more often. So I will recommend you to use this one and only the others if you are interested or you are curious about them. But this is the one I will finally recommend.
Perfect. Thank you very much. So please join the Slack channel. If you haven't done so, please visit the website. That's where you have all the information regarding the training program and all the links where you can connect with the coordinators and ask any questions if you have on the Slack channel. And we'll stop over here. And we thank you again very much, Santiago, for giving this training program, which was so interesting. And we'll meet tomorrow. So,
okay, thank you very much. Have a nice rest of the week. Bye.
Thank you. Goodbye, everybody.